This is Mrs. Hendry, and this is the Chapter 6 test video review. We're going to be going through problems that you will see that are similar to the ones on our test. First of all, in number 1, we are going to be combining like terms. And in this case, we need to use the distributive property first. And on the first part, we're going to be distributing this monomial. Look, there is no plus or minus, so we're going to distribute it straight through. 1/2 times 14 is 7. X squared times x squared. Remember, we're going to add these exponents because we're multiplying. That is x to the 4th. 1/2 times -8 is -4. And x squared times x to the 1st is x to the 3rd. 1/2 x squared times 10 plus 5x squared. Next, we're going to be distributing that minus sign, which is the same as distributing a -1. So, -10x cubed, -3x, and a plus 5. Essentially, having the minus sign there makes everything that follows it become the opposite. So now let's find the like terms. There's an x to the 4th. There are no other x to the 4th. Here's x cubed. Here's x cubed. There's an x squared. There's an x, and there's a constant. So let's put the like terms in descending order. Descending order has to do with the exponents. So we pick the biggest exponent first. It comes down first because there is nothing to combine with 7x to the 4th. Mark it off. -4x cubed, -10x cubed is -14x cubed. Notice that the exponents do not change when we add or subtract. Next, we've got 5x squared. It's the only one, so bring it down. Mark it off. Then -3x, bring it down, mark it off, and then a constant of plus 5. So this is in descending order: 4, 3, 2, 1, and none. So we always want to leave our answers in descending order when possible. Next, in number 2, we have a binomial times a binomial. So we are going to use the distributive property twice. So first, we are going to distribute the 5x through. 5x times 5x is 25x squared. 5x times -3 is -15x. Next, we're going to take the +3 through. +3 times 5x is plus 15x. +3 times -3 is -9. Now, the middle terms are the like terms in this particular problem. There's only one x squared. These are both x's, and of course that's a constant. But in this case, these middle terms cancel. These middle terms cancel because these two factors that we multiply together are known as conjugates. They have exactly the same terms in the same order, except one is a sum and one is a difference. And when we multiply them together, the middle terms will always cancel out. Conjugates, conjugates. So our final product is 25x squared minus 9. Why? They're conjugates, the middle terms cancel out. Now, this of course is different from what we see in number 3. In number 3, we are going to square a binomial quantity. So it might be helpful to rewrite this as 7x plus 7x plus 4 times 7x plus 4. And we are going to use the distributive property twice, just like we did in the previous problem. So take the 7x through. So 7x times 7x is 49x squared. 7x times 4 plus 28x. Now we're going to take the 4 through, and we get 4 times 7x, and I'll line these up vertically. 4 times 4 is plus 16. This time, the middle terms do not cancel. This time, the middle terms double. This time the middle terms double, and we get 49x squared plus 56x plus 16. And this particular product is special. We call that a perfect square trinomial. You can back it up on the Google site and you can watch a whole video about those perfect square trinomials. Last on the page here is number 4, and in number 4 we have a binomial times a trinomial. So we're still going to use the distributive property twice. First, let's take the 5x through. 5x times 3x squared is 15x to the third. Remember to add those exponents when you multiply. 5x times negative 10x is negative 50x squared. 5x times 2 is plus 10x. We took the 5x through. Now we're going to take the 4 through. And that is going to give us 4 times x squared is 12x squared. And yes, I am going to line up my like terms. 4 times negative 10 is negative 40x. 4 times 2 is plus 8. My like terms are lined up vertically, and I can add right down the columns. 15x cubed just comes straight down. Negative 50x squared plus 12x squared is negative 38x squared. Once again, when I add or subtract, the exponents are going to stay the same. They only change when we multiply or divide. 10x minus 40x is negative 30x, and then plus 8. That is your product of multiplying a binomial times a trinomial. Number 5, continuing to multiply. This time we have order of operations that have to be observed. So the first thing I want to call to your attention are the exponents that are outside of the parentheses. They need to be dealt with first. First thing, so everything inside those parentheses needs to be raised to the second power. Negative 2 squared is 4. X to the third squared. Power to power, multiply the exponents. Y squared is y squared. Next, 5 squared is 25. X to the fourth squared. Power to power, multiply. That's x to the eighth. Y to the third squared. Power to power, multiply. Now, we've gotten rid of the exponents that were outside of the parentheses. Now we can multiply these two monomials together. And we know they're monomials because there are no pluses or minuses in either of them. And when there's no pluses or minuses, we can easily change the order to help ourselves out. So 4 times 25. X to the 6th times x to the 8th. Y squared times y to the 6th. We can do this because they are monomials. If there are pluses and minuses, we cannot do this. 4 times 25 is 100. X to the 6th times x to the 8th. Now we are multiplying and the bases are the same. Add the exponents. Y squared times y to the 6th is y to the 8th. 100, x to the 14th, y to the 8th. Number 6 is a combine like terms once again. And when we combine like terms, remember to follow order of operations. So I'm going to use the distributive properties here and here and here. So negative 7a to the third times a is negative 7a to the fourth. Negative 7a to the third times a negative 3 is plus 21a cubed. Plus 2a times 3a cubed is 6a to the fourth. 2a times 7a plus 14a squared. And then remember, if we have a negative 1 that precedes parentheses, it's just like multiplying by negative 1. So negative 4a squared and a negative 5. Once again, let's find the like terms. There's an x to the fourth. There's an x to the fourth. There's an x cubed. There are no other x cubes. Here we have an a squared and another a squared and a constant. Remember to put your answer in descending order. Always start with the largest exponent and then go down from there. So negative 7a to the fourth, positive 6a to the fourth is negative 1a to the fourth. Mark them off. Then we've got an a cubed. This is the only one, so bring it down. Then we have 14a squared minus 4a squared. That is plus 10a squared. And then there is no a term. Since there is no a term, the 5 comes straight down. 4, 3, 2, and none. Descending order. Number 7, we're reducing a radical. And when we reduce a radical, the first thing we need to do is make a factor ladder for what is underneath the radical. So 48. Remember, factor ladders, we're only going to divide by prime numbers. That is what we are after. So the 48 divided by 2 is 24. 24 divided by 2 is 12. 12 divided by 2 is 6. 6 divided by 2 is 3. Remember, these should all be prime numbers because we are after a prime power factorization, a PPF. There's a whole video on that. So we're going to replace the 48 with our prime power factorization, and then we will reduce the radical. 1, 2, 3, 4. 2 to the fourth times 3 to the first times s to the fifth times t to the 12th. Now from there, we are going to compare the index of the radical with each one of those powers in our PPF. And out front, 2s cubed t squared is just going to get multiplied by whatever we're about to bring out. So 4 goes into 4 one whole time. That's why 1 power of 2 is going to come out. 4 will not go into 1. That is why the 3 to the first has to stay under. 4 goes into 5 one whole time with 1 left over. 4 goes into 12 3 times exactly. So we just simplify the radical by using the prime power factorization. So now we're going to multiply together what's out front. So 2 times 2 is 4. S to the third times s to the first is s to the fourth. Add the exponents there. T squared times t cubed is t to the fifth. Add the exponents. And then underneath the radical remains the 3s. So there is your final simplified result for this radical expression. Last problem here in the video review is number 8, 10 to the 1/2 times 25 to the negative 3/2. Just as a reminder, the 1/2 power means exactly the same thing as the square root. And the square root of 100, everyone should know, is 10. So there's the first part. And we're following order of operations here. We're dealing with the exponents first. Now, I'm going to highlight the fact that this is a negative exponent. And negative exponents do not make negative numbers. They make fractions. So I am going to come over here in my little box and say 25 to the negative 3/2 is equal to 1 over 25 to the positive 3/2. All I have to do is reciprocate this term, and then the exponent goes from being negative to being positive. So if the denominator of the fraction is the index of the radical, I have 1 over the square root of 25 raised to the third. And if we follow order of operations here, the square root of 25 is 5, and 5 to the third is 5 times 5 times 5, so that's 25 times 5, that's 125. 25 to the negative 3/2 is 1 over 125. So I'm ending up with 10 times 1 over 125. So this just becomes basic fraction multiplication. 10 over 1 times 1 over 125. So if we make this into one fraction, and then we can simplify that fraction by simply dividing top and bottom by 5, I get 2 over 25. And that is the reduced product of 10 to the half, or excuse me, 100 to the half, and 25 to the negative 3/2. One more time. The denominator of the fractional exponent is the index of the radical.